I see this question pop up all the time in forums, in comments. Should I use a Bayesian network or should I use MCMC for my project? And look, it sounds like a totally fair question, but it's actually based on a fundamental misunderstanding. So let's clear this up once and for all. Asking whether to use a Bayesian network or MCMC is exactly like asking this question right here. And yeah, that question sounds completely ridiculous, right? I mean, one is a plan, the other is a tool. You don't choose between them. You need both to actually build something. And that is the single most important idea we're going to talk about today.
All right, so let's just cut to the chase. Here's the entire thesis of this explainer, right up front. A Bayesian network is the model. It's the what. It's the thing you are trying to build. MCMC, on the other hand, is the algorithm. It's the how. It's how you actually get answers from that model you built. You don't choose one or the other. You use them together.
Okay, so first things first. Let's talk about the plan, the architecture itself. This is the world of the Bayesian network. So what is it really? Think of it like a drawing of your problem. It's a graph where each little circle or node is a variable you care about, and the arrows between them show you how they influence each other. And that fancy term, directed acyclic graph or DAG, all it means is the arrows only go one way, and you can't have them circle back on themselves. No loops. This slide really lays out the whole landscape for us. Over on the left, you've got the Bayesian network. We're calling it the probabilistic blueprint. This is our game plan. It helps us break down a huge, messy picture into smaller, understandable parts. You see that classic example right there? Rain and sprinkler can both cause the grass to be wet. This little diagram is our blueprint for this tiny slice of reality. We'll get to that computational engine on the right in just a minute. So why do we even bother drawing this blueprint? Well, because the real world is an absolute mess. Trying to calculate the probability of everything happening together at once, what we call the joint probability, is a complete nightmare. Bayesian networks are brilliant because they let us take that terrifyingly huge problem and chop it up into simple, bite-sized pieces. Like, okay, what's the probability the sprinkler is on if it's already raining? Much easier to handle. Okay, great. We've got our map. But here's where we slam into a brick wall. We want to ask interesting questions, right? Like, okay, I see the grass is wet. What's the chance it was because of rain? Answering that takes math. And as soon as our blueprint has more than just a handful of variables, that math doesn't just get difficult, it becomes literally physically impossible to solve exactly.
So, our beautiful blueprint is drawn, but we can't actually build anything from it yet. We need a builder. We need a tool that can actually work with this complex plan. And this is where MCMC enters the chat.
This problem actually has a name, and it sounds as scary as it is: the curse of dimensionality. When you have a network with, say, 50 interconnected variables, the total number of possibilities you'd have to calculate just explodes. We're not talking big numbers. We're talking numbers so vast they make astronomical figures look tiny. You literally couldn't solve it. And that's where MCMC becomes our secret weapon. It's an algorithm that takes one look at that impossible equation and says, nope, not going to do it. Instead, it takes a much cleverer approach. It explores the world you designed in your blueprint by running a simulation, kind of like a super smart guess and check system. So how does this smart guesser actually pull it off? The classic analogy, and it's a great one, is the drunk walk. Imagine the algorithm is dropped at a random point on your map. It takes a random, stumbling step to a new spot. Then it looks around and asks, is this spot more plausible than where I just was? If the new spot is more probable, it's very likely to stay. If it's less probable, it might still check it out, but it'll probably stumble back. Over thousands, even millions of these little steps, the path it carves out shows us exactly where the most likely answers are hiding, because that's where it spent all its time. All right, let's tie this all together with the visual here. The Bayesian network on the left, that's our map, our blueprint. But we hit that wall of complexity, which tells us that exact math is a dead end for any interesting problem. That's where the computational engine on the right, MCMC inference, becomes our hero. It's the builder. It's the heavy machinery that uses that clever drunk walk to explore the world our blueprint created, and it finds the answers without ever needing to solve that impossible equation. Okay, so let's zoom in on how this actually works in practice, bringing our blueprint and our builder together into a real workflow. This table just nails the comparison. Look at the role. The network is the architecture. MCMC is the computation. The analogy, it's the map versus the explorer. And this is super important. Check out the output. The network itself just gives you the graph, the static blueprint.
MCMC, though, gives you a dynamic stream of samples from that world. That's what we see in those fuzzy caterpillar trace plots, a literal record of where the algorithm explored. Honestly, this quote just wraps it all up in a neat little package. It's a two-step dance. You, the expert, define the world with your network. Then you unleash MCMC to go find the secrets hidden in the world you just created. So the whole process, the entire workflow we've been talking about, really boils down to these 3 simple steps. Step 1, on the left, you build your blueprint, your Bayesian network that describes the problem. Step 2, in the middle, you immediately recognize you've hit that wall of complexity, and that exact math isn't an option. So step 3, on the right, you hand the keys to your computational engine, an MCMC sampler, and tell it to go explore.
All right, enough theory. Let's make this real. How does all of this connect to the tools you're probably using every single day?
If you have ever used a library like PyMC or Stan, congratulations, you've already been doing this all along. When you're in your code, defining your priors and likelihoods and how all your variables are connected, you're literally building a Bayesian network. And that little line of code, pm.sample, that's you hitting the big green go button and telling your MCMC algorithm to start exploring the network you just designed.
So from now on, here's your new rule. The question is never, should I use a Bayesian network or MCMC? That's the wrong question. The real job, the art, is in building a better network, a blueprint that actually captures the important parts of your problem. Once you've done that, you just pick the fastest, most efficient builder, the best MCMC sampler for the job, to get your answers. Focus on the blueprint first.
And this leads us to one last really important question. If MCMC is basically just walking through our model, and some models are like vast, mountainous landscapes, are some ways of walking smarter than others? Is there a better way to explore than just stumbling around randomly?
Oh, you bet there is. And believe it or not, it uses the laws of physics to do it. Next time, we're diving deep into Hamiltonian Monte Carlo. It's the supercharged engine inside tools like Stan and PyMC that makes exploring today's massive models not just possible, but incredibly efficient. Trust me, you're not going to want to miss it.